The purpose of our simulation model is to better understand how changes in our actual real-life plant are affected by changes to our inputs, such as processing times at processors or stations, how things flow through our plant, how much buildup we have at certain station, where we are storing our inventory, and all of those things can be modeled in these simulation windows. So let's take a look at what happens when we want to take two different products into two different spaces. So let's say we're going to take our mountain bikes to a certain processor to add shocks, but our road bikes don't have shocks, so the frame is adjusted differently. So how would we create that? We're going to have to add a second processor. So I'm going to pull a processor here, and I'm going to connect this up. And I'm also going to rename these processors just so I can distinguish between mountain bikes, mountain, apply OK, and processor 12 will be our road bikes. Apply OK. Now I'm going to reset this model so that Flexum knows what I'm doing here. And I'll slow my speed down a little bit and run it. So let's take a look. I'll run this for about 60 seconds and then we'll stop. I'll keep running it so we have some. So we're actually having no trouble keeping up with the flow. There's not a whole lot of buildup in the queue. This is one of the first times I've seen that. And when I highlight the statistics, the mountain processor is moving 64% of the time, and this one's 53%, so a little bit less. So there's been 6 and 7. If we keep running this for a while, let's see if that changes. Stop. Mountain bike 81%, and the road bike 70%. So why is the mountain bike processor busier? Well, it's because of how we have the flow items flowing. And right now, we're not distinguishing between where it goes where. And that is because in our queue, the upstream object, this is where the flow is dictated. So under the flow tab in our properties box, there is something under output that says send to port. And the default setting is first available. So it's going to look at the two different ports, and let's refresh our memories on what ports are. Under the general tab, our output ports are 1 and 2, mountain and road. And it's saying go to the first one available. So it looks to the first port, mountain, and it says, okay, I'll go to you first. If you're busy, I'll go to road. So that is why mountain bikes are busier. But what we would really like to do is we don't want it to go to first available. We want mountain bikes to go to the mountain processor, and we want road bikes to go to the road processor. So let's look at the pick down list here and see what options we have. So there's a whole bunch of different ways to do the same thing. And in this case, let's say, we'll go use some fancy code. So get item type, bracket item. This is a piece of code that means read what is in the flow item box for item type. So in this case, for this box on the mountain bike processor, it would say, okay, well, it's too late actually. It should be up here. But if this was upstream, it would say, okay, read this item type and then send it to whatever port it says on there. So if I apply this setting, reset, and run it, what do you notice about the colors? We only see reds in the mountain bikes, and we only see green under road bikes. So what we're doing now is upstream in the flow tab, it's saying, read the item type. That's what this code means. Read the item type before you send it. So this red guy is item type 1. Send it to that port, output port 1. So we match up the item type with the output port. Now, if we connected road bikes first, and I can change that by changing the rank here, then what would happen is that it's going to send item type 1s to road. But we've already decided that item type 1s are mountain bike, so that would be wrong. So I need to make sure that these are in the right order. And the order they go in is basically essentially exactly how you connect them. So I connected this mountain bike processor up first and then this one second, so it became the second port. So now again what we have is we have our flow items going to the right place because we are deciding upstream where it's going. I'll show you another way to do this. If we went to port by case, we could also read the item type and say, in case 1, go to port 1. In case 2, go to port 2. That's just a longer way to do the same thing. We could also do, let's see, what's the other one? Conditional port, perhaps? Nah, that looks more complicated. By expression, get item type by item. That's the one that I will use 90% of the time. So now we have our mountain bikes getting their shocks put on and the road bike getting a different frame altogether. Because the flow of these item types are determined upstream, this way of flowing or routing your items is push scheduling. And I'll show you how to use pull scheduling in another video.